Alright, hi everyone. So we are in the third lesson for our topic for differentiation. So for today's learning outcome is pretty simple. So we are going to learn how to use the derivative for some of the trigonometry function. So these four are the functions that you will need to learn how to differentiate them and also apply them together with constant multiple, sum, differences, composite, and also the product rule and the quotient rule as well. Okay, so derivative for sine -1x and cos -1x are not required in your syllabus. Okay, so let us start the lesson. Alright, okay, for this lesson, I'm not going to explain the process, how do they actually get the derivative for sine, cos, tangent, because somehow in the process itself, it will require some extra knowledge for you for the first principle or even the limit, which is not required in your syllabus, and I do not want to confuse you, and also I want to keep the video shorter today because you just had your test as well. Okay, so we are just going to look at the formula and know how to use them. Okay, so these are the formula for the derivative for sine x, cos x, and tangent x, and this will be given in your exam as well. Okay, so don't worry about memorizing them. Okay, so let's start with the first one. If y equals to sine x, when you differentiate sine x, you will get cos x. Okay, so that's the first one. Second one, when you differentiate cos x, you are going to get negative sine x. Okay, the third one, when you differentiate tangent x, you are going to get secant square x. Okay, all right. So, but then, of course, if you are interested to know how do they find this, then I think you can try to search it out in a video and so on. Yeah, I mean, don't worry about whether understanding them or not because you are not required to derive it in your exam. Okay, but then we are still going to derive the one for sine fx, cos fx, and tangent fx because this formula will not be given in your exam, and in case if you forgot how to do that, then you still can use the chain rule to help you to actually solve this. Okay, so we are coming back to this later. So let's try to see the fourth one, which is the derivative for tangent -1x. Okay, so please do not confuse yourself that tangent -1x is not 1 over tangent x, okay? And of course, it's not cotangent x as well. So they are different things. So tangent power of -1x, we are talking about, for example, if you have, let's say, x equal to tangent y. So how do you actually solve y? So you will be doing like y equals to shift tangent in your calculator, right? Then after that, for you to get the value of y. So this is what you do. So meaning that we are going to do dy dx for this one. Okay, so what do we get after we differentiate the tangent -1x? So we are getting 1 over 1 plus x squared. Okay, so same thing, if you are interested to know how do they derive this, then you can check on YouTube and so on to get the video. All right, but the idea is you just need to know how do you use it. Okay, so just remember the four formula that we have learned just now. Then after that, we are going to look at the first example here. Okay, before we move on to the next part, which we try to derive the one for fx. Okay, so let's try to look at questions one. So we start with A, which is an easy one. So I have put on the formula up here so it's easier for us to refer. So A, y equals to 2 sine x. So this is like a random multiple lah. Okay, so sorry, a constant multiple. So you straight away multiply. It's the same thing like when you do 2x, then you just differentiate the x, right? Okay, so dy dx, so the 2 still stays the same. Then after that, you differentiate sine x, which gives you cos x. Okay, so let's move on to B. So B, y equal to x cos x. Okay, so you can see this one, we can't actually expand them because, I mean, you are not going to put another x put in the cos function, right? So that's why this is like a UV form. So that's why let u equals to uv, and we try to do product rule. So u equals to x, then after that v equals to cos x. Okay, so differentiate du dx, you get 1, and then dv dx. So when you differentiate cos x, what do you get? You get negative sine x. Okay, so let's continue with differentiation. So dy dx will be equals to u dv dx, and then plus v du dx. Okay, so u is x, dv dx negative sine x, plus v cos x, and then du dx is 1. Okay, so let us just try to rewrite it without the bracket and try to put it nicely. Okay, so you have negative x sine x, and after that plus cos x. Okay, so now let's move on to C. Okay, let's continue with C. So same thing, y equal to tangent x over x squared. So this is the same thing also. You can't actually cancel off the square and the x there, right? Because the term is tangent x. So that's why we need to use y equals to u over v, which is quotient rule, to help us to solve. Okay, so u equals to tangent x. So when you differentiate tangent, then you get secant square. So du dx equal to secant square x. So same thing, v equal to x squared. So when you do differentiation, then you will get 2x. Okay, so next you can try to put them together. So dy dx will be equals to v du dx minus u dv dx, and then divide by v squared, right? Okay, so substitute x squared secant x squared minus tangent x, and after that you have a 2x. So make sure you don't confuse with that, then maybe you can write 2x in front. So 2x, then after that tangent x. Okay, so divide the whole thing by v squared. So v squared is v squared, so v to the power of 4. Okay, then after that, please check, do you have anything that you can actually simplify in this case? So you can see you have both x, right, for the denominator part and the numerator part. Okay, so the x here and the x here. So if you want, then you can try to write factorization first lah. So if you're not, then you can straight away just cancel it. Minus 2 tangent x, and then after that divide by, sorry, the whole thing. Okay, and then divide by x cubed, then x. Okay, so you have xx. So now you can try to simplify it. So you get your last answer as x secant x minus 2 tangent x over x cubed. Okay, yeah, you can just leave your answer like that. All right, so let's move on to D. Okay, so D, y equal to 3 plus 2 sine x to the power of 5. Okay, so I think this one obviously you need to do composite already. So dy dx equal to, okay, power, move it into front, so 5, copy whatever inside the bracket, and then power minus 1, and don't forget you need to differentiate what's inside your bracket. Okay, so 3 differentiate, you get 0, then 2 sine x, so after differentiate you get 2 cos x. Okay, so simplify it, the first term and the coefficient in front, you can try to multiply them together. So you get 10 cos x, then after that 3 plus 2 sine x to the power of 4. Okay, all right, so let's look at the last one. Okay, so y equals to exponential power x, and then tangent negative 1x. Okay, so don't be panic when you look at this. So you just solve it like normally how you solve like b. Yeah, so they are the same idea. So we try to use y equals to uv. Okay, so what is the u? U is exponential x, then after that v is tangent negative 1x. Okay, so let us differentiate them. So when you differentiate ex, then you get exactly the same thing, right? Then after that, same thing, dv dx Okay, so tangent negative 1x, after you actually differentiate, then you are getting 1 over 1 plus x squared. Okay, so as simple as that, then we try to put them together. So dy dx equal to u dv dx plus v du dx. Okay, so u is ex and then dv dx is 1 over 1 plus x squared plus v tangent negative 1x. So make sure you try to put a bracket so you separate them. So du dx is ex. Okay, so now you can just try to rearrange them together. So you have both ex, right? So you can just ex. Okay, then after that, combine the next term. So 1 over 1 plus x squared plus shift tangent negative 1x. Okay, so please do not change this form into 1 over tangent x. So we have discussed this in the previous part where I give you the formula already. Okay, so you can just leave your answer like this. Alright, so let's move on to the next part, which we talk about the derivative for fx. Alright, so now let's look at the second part, which we need to learn how to derive the derivative for sine, cos, tangent function f of x. Okay, so we will try to use the same idea as what we have tried to practice so far for the natural base and actually for natural logarithm as well. Okay, so we try to consider the function of sine y equal to sine fx. Okay, so what we will try to do is same thing. So we try to let y equal to sine u. Okay, so if y equals to sine u, meaning that u will be equals to function f of x, right? Okay, so now we try to differentiate. So dy du. So when you differentiate sine u, then you are getting cos u. So for u, when you differentiate du dx, then you can get f prime x as well. Okay, so now we try to use chain rule and combine them together. So dy dx equal to dy over du multiplied by du over dx. Okay, so dy du is cos u, and after that multiply by du dx is f prime x. Okay, then we substitute back the u because we want dy dx, right? So what is u? So u is fx. So that's why we try to rearrange this as well. So f prime x, and after that cos fx. Okay, so in short, what is this mean is just that when you have cos fx, then what you need to do, you need to differentiate what is in the bracket, then you will write it before your cos, which means it will become a multiply lah. Then after that, whatever in the bracket is not going to change. Okay, so the same thing will apply to cos and tangent as well. So we can try to write it down here. Okay, so if your y is equal to sine fx, then dy dx will be equal to f prime x cos fx. Okay, so same thing, if you have y equal to cos fx, what happens? So you remember when you try to differentiate cos, then you get negative sign, right? So dy dx, same thing, you need to differentiate whatever function in the bracket, then after that you will become negative, then sine fx. Okay, so move on to the next one, the last one, which is a tangent. Y equal to tangent fx. So when you actually differentiate it, dy dx, then you get f prime x as well. And after that, second square fx. Okay, so this is something that you might be very careful that because this will not be given in your exam because they actually assume you to know that how do you actually do this by using chain rule. Okay, So that's why you will need to remember it by yourself. All right, so let's move on to the next one. So the same thing, we try to consider the function y equal to tangent negative 1 then fx. Okay, so we try to do the same thing as well. So let y equal to tangent negative 1 u, and then u equals to fx. Okay, so let us expand it. Sorry, not expand, differentiate it. So dy du. So for this one, after you differentiate, you get 1 over 1 plus x squared, right? Then after that, move on to the next one. So which you differentiate this, then du dx, which gives you differentiated form in x. Okay, so now let's use the chain rule to combine them together. So dy dx will be equal to dy over du multiplied with du over dx. So dy du equals to 1 over 1 plus, I'm sorry, this is u squared. Yeah, because tangent negative 1 u, right? So that's why it should be u. So 1 plus u square. Okay, then multiply with f prime x. Okay, so now let's continue to simplify that. Then after that, you can see what is u. U is function of x. So you can f prime x divide by 1 plus fx square. Okay, so this will be a little bit more complicated if you compare to the sine cos tangent just now. But it's basically the same thing which you need to differentiate what is your what is inside your function. Then after that you will multiply it with the function square. Okay, so try to write it over here. So if you have y equal to tangent negative 1 f of x, then when you expand, when you differentiate, okay, then you'll be getting f prime x over 1 plus fx squared. Okay, so now let's try to use it in the questions too. Okay, so let us write down the formula that we have learned just now so you can try to use it. So y equal to sine fx. Okay, so what you will get, then when you do your dy dx, you will need to differentiate whatever that is inside, then after that sign, so you write the same thing for the bracket. Okay, so it's going to be similar like this, but you are going to write negative sign then this one also. Okay, so for tangent negative 1, then it will be y equal to tangent negative 1 fx as well. So when you try to expand it, so I mean, if you think that it's easier for you to remember in that way, then you can try to think it like you need to multiply with f prime x also. Then after that, this is the original that you have, right? So 1 over, so you are just changing your x into f of x. So 1 plus f of x. Okay, so you can try to remember it like this if it's easier for you, because you see it's going to be the same thing that you try to substitute the x, then change it to fx, then after that you need to multiply the derivative for fx. So it's the same thing, you try to change the x part into f of x, then after that you differentiate and multiply. Okay, or in the other way, then you can just write it like what we have learned just now. So you just want 1 over then f of x then square. Okay, they means the same thing lah. It's totally fine if you remember like this, then later you expand it again. But make sure that maybe you might need to put another bracket here so it's easier to, yeah, so you don't get confused later. Okay, so let's try with A. Okay, so A, y equal to 2 sine 3x. Alright, so your dy dx, so same thing, 2 is just a constant, right? So you can just leave it. Then after that, sine 3x, so you need to differentiate your 3x first. Then what do you get? You get 3. So sine, after you differentiate, you get cos, right? So cos, then after that, your function doesn't change, so 3x. Okay, so x you expand, then you get 6 cos 3x. Alright, so let's move on to B. Y equal to 4x tangent 2x. Okay, So same thing, you can realize that this is not a constant which you have an x. So that's why u equal to uv, then after that u equal to 4x, and then v equal to tangent to x. Okay, so differentiate 4x, sorry, dy or du over dx. Okay, then you get 4. So for this part, dv dx. So what do you get when you differentiate tangent to x? So 2x differentiate, you get 2. Tangent will change to secant square, then function, just write it. Alright, so now let us combine them in the formula. So y equal to v du, sorry, let me try to follow your book. Yeah, dv dx, then after that plus v du dx. Okay, so 4x multiply with 2 secant square 2x plus, maybe we write 4 first, tangent 2x. Okay, then now we can try to simplify them to write it in a better way. So 8x secant square 2x plus 4 tangent 2x. So this is your last answer. Okay, so let us move on to C. Okay, so C, y equal to 7 tangent 4x plus pi over 2. Okay, so don't panic when you see this type of question. You just treat it like, because pi over 2 is basically just a constant, right? So that's why you just treat it like a normal number. Okay, so do you think that you need to do uv and so on? No, actually you have one function only, which is with the 4x here. Okay, so you can just differentiate it like normally. So dy dx. Okay, so 7, you will just write it. So differentiate whatever inside your bracket. So 4x plus pi over 2, when you differentiate, what do you get? You get a 4, right? Then after that, tangent, you will change to secant square. Okay, then after that, copy whatever that is inside. Okay, so next, you just try to combine them together. So 28 secant square 4x plus pi over 2. Okay, okay, so something important that I would want to actually note here is that please make sure that all the angles, right, that actually involved in your calculus, so meaning no matter in your integration in future or like differentiation, where we try to talk about pi over 2, right, it will be always in radian. So please make sure that if let's say you have any calculation that you want to do, let's say if you are solving for dy dx equals to 0, so please make sure that you don't change the pi into like 180 then divide by 2 and so on, because this is not a degree. So please make sure that you treat everything as radian. So unless the question purposely tell you that it's in degree, but it's actually quite rare they try to do that. So when you try to go through your exercise or even your past year, you can see that all the questions that involve sine, cos, tangent in calculus, right, all the angles will be normally measured in radian one. Okay, so please make sure that you note this in your note, that maybe you just write it in your notes that all angles in calculus are measured in radian. Okay, so you can just try to remind yourself lah, that you don't treat it as a degree. Okay, all right, so let's move on to D. Okay, so this is the same thing. So it will be an easy one. So y equal to 3 minus 2 cos 5x to the power of 4. Okay, so obviously this is a composite. So what do we need to do? So same thing, dy dx equal to, so 4 power, so bring it to front, then after that copy exactly whatever that you have in the bracket, power minus 1, which you got 3, then after that differentiate what is inside. So 3 is a constant, so after you differentiate you get nothing. Then after that cos, after you differentiate you should get a negative sign, right? So negative negative, it will become positive. So 5, you remember to multiply, so you get 10 sine x. Okay, so this is what you have. Then after that, let's continue. Equal to, oh, I'm sorry, it should be 10 sine 5x. Yeah, so make sure your fx doesn't change. So your 5 you differentiate 5x, you get 5, so multiply with 2, you get 10. Then after that, still sine cos x. Okay, then maybe we can try to simplify them. So 4 times 10, you get 40 sine 5x. Then after that, multiply with 3 minus 2 cos 5x to the power of 3. Okay, so let's move on to E and F, which we talk about tangent -1. Okay, so let us try to look at E. So E, y equal to tangent -1 square root x. Okay, so let us try to change this into indices first. So you have x, then 1 over 2. Okay, so let us try to put it in the formula. So dy dx, okay, differentiate the part for this one first. So you have 1 over 2 x and then -1 over 2, right? So differentiate your function. Then after that, it will 1 over, maybe let me try to change. So 1 over, okay, 1 plus, so the whole thing for your function. So if you do not want to write it in this term, so yeah, I mean, yeah, it's the same lah. So 1 over 2, then after that, don't forget you need to square it. Okay, then close it. All right, so now you can start to simplify. So 1 over 2 x, then after that you can see x to the power of 1 over 2, then you have power 2 as well, right? So you're left with x, so meaning you have 1 over 1 plus x. Okay, so you can just leave your answer like this, as simple as that. Okay, so let's move on to F. So same thing, y equal to tangent -1 to x squared minus x. Okay, then after that, you can straight away do your dy dx already. All right, so differentiate your function first. So after you differentiate 2x squared minus x, then you have 4x minus 1, correct? Then after that, 1 over, so your whole function need to square. So 1 plus whole function square. Okay, so for this one, I mean, even you try to expand it, you also cannot simplify further already. So you can just leave your answer like that. But maybe we can try to put this as the numerator. So 4x minus 1 over 1 plus 2x squared minus x squared. Okay, so that's it. It's quite short for the lesson today. So I hope that you can take this time to do your exercise. And just for your information, right? Because the Cambridge book is actually published before 2020, and the part for the syllabus for tangent -1, right, is actually a new syllabus starting from 2020. So that's why you will realize that there will be no questions about tangent -1 over here. So if you want, then you can find it out like online and so on to get some extra exercise for you to do that. Okay, so that's it for today's lesson. Thank you.